various expertise, and assisted by 2 administrative staff and 6 professional technicians. As facilities, MEVE has 8 laboratories with qualified equipment, staff offices, comfortable classroom, library with a collection of reference books and scientific journals, student association office, cafeteria, and student lounge with a comfortable green garden and others. In the fabrication laboratory, lecturer students can study and conduct research on sheet metal forming and welding technologies. This laboratory provides some qualified equipment such as 1. ACDC SMAW and GTAW welding machine with 11 kVA capacity. 2. Controllable hydraulic cutting machine which can cut 8 mm thick plates. 3. 4.5 kVA spot welding machine which can weld 1.2 mm thick plates. 4. Steel blending machine for a plate thickness of 3 mm and a width of 900 mm. The next is machining laboratory. It provides conventional and semi-conventional mechanical machine such as 1. Maximum lathe machine to make 60 cm shaft with max speed of 1100 revolution per minute. 2. Vertical milling machine with traverse length of 40 cm and maximum tools diameters of 16 mm. 3. Horizontal milling machine with some tools like dividing heads, cutter modules, slab milling, slotting, and grooving. To study non-conventional machine, MEVE possesses CNC laboratory with some equipment such as 1. CNC filler VMP40A with 1 meter displacement length and speed of 10,000 revolution per minute. 2. 3D printer Felix Pro 2 machine to print objects with a height of 30 centimeters. 3. MCO TU2A and TU3A CNC machine with movement accuracy up to 0.01 mm and a maximum feeding power of 1 kN. MEVE provides 40 computers in the engineering design laboratory with high specification. Students can design product prototypes here, develop algorithm and coding, and use CFD software for numerical analysis. For machine structure analysis, MEVE provides construction laboratory with some equipment. 1. Shear rod test equipment. 2. Steel truss load test to determine the stress of material with a maximum load of 60 Newton. In the energy conversion laboratory, some equipments can be used for learning and research activities, such as 1. Hydraulic and pneumatic trainer kit. 2. Bomb calorimeter to measure the calorie content of the fuel material. 4. For material analysis and testing, MEVE provides a materials laboratory with some equipment such as 1. Double disc grinder and surface polisher with adjustable rotating speed. 2. Brinell, Vickers, and Rockwell hardness testing device with a maximum capacity of 3000 kg force. 3. Impact testing device with a Sharpie method and a maximum load of 800 kg force. 4. Microscope for 1000 times magnification. 5. Provide projector CCV 140426 for 20 times magnification. 6. The Hoffman furnace with a maximum temperature of 1000 degrees Celsius. The last one is manufacturer laboratory with some equipment. 1. Universal testing machine for bending tensile and fatigue test with load capacity of 50 kN. 2. Ultrasonic flow detector for undersurface material damage testing. 3. Magnetic particle inspection for analysis of metal surface defect due to welding machining process.
Hello, Doctor. Dr. Binitha.
Yes. Kiki, can you hear me?
Yes, I can hear you. You can hear my voice clearly?
Yes. It is very clear.
Okay. Is it okay with your video, the camera?
Yes.
Okay. Are Silija and Suraja also join with us?
Pardon?
Silija and Suraja?
Maybe. They may be joining. Yes.
I miss them. How are you, Doctor?
Fine.
Thank you. Maybe we can waiting for the participant to come to join, and also editor in chief. Maybe he will join with us in shortly.
Okay.
Have you contacted with the Dr. Zahira, Prof. Zahira?
Yes.
Okay, it's good, great.
Uh,
Oh, there is Anila also. Anila. Oh.
yes, she's there.
We have a mini reunion in this symposium.
Yes.
Okay, we are waiting for the participant to join. Actually, we provide around 500 participants.
Oh.
But maybe in time management, 15 minutes we will start the symposium.
Okay.
Is it okay now there in India, in Kerala, the pandemic?
In India, it is almost in control, but our state is not yet safe. But it is decreasing.
Decrease.
Decreased.
Oh, thanks
But
God, it's decreasing.
still cases are there. Our
Yeah.
state is maybe daily about more than 10,000 cases are there.
How about the school? Already open?
Next month it will be opening.
Oh, next month. Okay.
Yes.
Also in Indonesia, some private school already open, and some of them are still online class.
Okay.
Some in India. In Indonesia also the case is in decreased.
Yes.
Vaccine? Have you vaccinated?
Yes, vaccinated.
Twice or once?
Yes, two.
Moderna or what? Or what vaccine?
Covishield, Moderna vaccine. Yes.
Oh, that's good. For us in Indonesia, Moderna is just especially for medical staff.
Oh.
For the civil, we have Sinovac.
Okay.
Whatever is, I think, I hope the pandemic will be over soon.
Okay.
We have maybe from Thailand, and also from your students. I see your student, many of your students join with us. Okay, I see. Some of them also my students. Now I working in a mechanical engineering department.
Oh.
But in especially expertise in energy, renewable energy.
Oh, in biodiesel itself?
Pardon?
In biodiesel?
Yeah, still in biodiesel and also in oil crop, with cooking oil, over to biodiesel and some of that. Still in my core in energy.
Okay.
And about you, doctor?
I mean materials itself. Graphene is mainly doing. Yes.
Yeah, I saw your latest publication. Right?
Yes.
In your chemistry journal.
Yes.
It's also about the graphene, right?
Yeah. We are mainly doing with graphene now.
Graphene. Still collaborated with Professor Zahira?
Yes.
Oh, it's good. You still connected with her.
Yes.
It's good. I also wants to connect it with her, but since I left Malaysia in 2014, I lost her contact. Last time when you asked her mobile number, I searched it in Kak Nini, Puan Nini.
Okay.
We have also student and also lecturer from other university. I see there is a Dwi Kemala Putri. She is from Polytechnic Ati Padang. And also, okay, Anila. Suraja. Oh, maybe I will ask the. Okay. Are you ready, doctor? We will start.
Okay, we can start.
Okay, check. May I have your attention, please? Can you hear my voice clearly? Yes, I think it's quite clear. We will start our symposium in shortly, and I hope all of you to mute the voice to avoid interruption. Okay, good afternoon and Assalamualaikum warahmatullahi wabarakatuh. Your Excellencies, Rector of Universitas Negeri Padang, Prof. Ganefri, Dean of Faculty of Engineering, Universitas Negeri Padang, and also Honorable Editor-in-Chief, Professor Syahril, MSc PhD, Honorable Speaker, Dr. Binitha Narayanan, fellow students, and ladies and gentlemen. It is my pleasure to be an MC and moderator for this symposium organized by Teknomekanik Journal, Department of Mechanical Engineering, Faculty of Engineering, Universitas Negeri Padang. I am Sree Putri Pemandari PhD. On behalf of Teknomekanik Journal and the committees, I would like to extend a warm welcome to all of you. We appreciate you to taking time off your busy schedule to join us today. Okay. To opening this event, we are pleased to have Professor Syahril, MSc PhD, our Editor-in-Chief of Teknomekanik Journal, to deliver the opening remarks. Professor Syahril, please, time is yours. Prof. Syahril?
Okay, thank you, Rizky.
You're welcome, sir.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, the Honorable Director of University Negeri Padang, Prof. Ganefri PhD, the Honorable Dean of Engineering Faculty, Dr. Fahmi Rizal, the Honorable of the Head of Mechanical Engineering, Department Mr. Purwantono, and with all lecture, staff, and committee. The special our speaker, Dr. Binitha, from Sree Neekalanta Government Sanskrit College, India. Thank you for your sharing your knowledge, and all respectable attendants. Ladies and gentlemen, let us thank to Allah who has given us every good soul. Today, we can see Ojar virtual here to join this event. I have appreciation to the committee who has working hard to hold this symposium. This event is the first international symposium week is presented by Teknomekanik Journal, organized by Department of Mechanical Engineering Faculty, Universitas Negeri Padang in West Sumatra. For your information, it's an international journal which is dedicated to the improvement and disseminate to knowledge on method, policies, and technologies in technical science and vocational education. It's welcome to contribute from all who wish to report and new develop and latest finding in engineering, new trend, and new progress provide to practice in listed in file. Creating a unique forum or platform for interdisciplinary and multidimensional knowledge. Teknomekanik journal published 2 issues in a year, and it has been indexed by Sinta for Google Scholar, Garuda, Dimension, and Crossref. So everyone who has qualified article is fall within this area. Please do not hesitate to send them to Technology Mechanic Journal for publication. Ladies and gentlemen, in this symposium, we will have 2 outstanding speakers, Dr. Binitha. Dr. Binitha will present her paper entitled Ball Mill Assistant Green on Pot Synthetic of Zinc Oxide / Graphene Nanocomposite. This means material for selective electrochemical sensing of aquatic pollutant for Nitrophenol. The paper contains updated knowledge so that we can get new input and understanding from it. So everyone please follow this symposium well and take a good advance of the question and answer session. Last, I am as editor and chief of Teknomekanik Journal. Once more, would like to welcome you all to this international symposium and hope this event will be benefit to everybody. Now, I officially open this symposium by saying Bismillahirrahmanirrahim. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, sir, for the great remarks. Give applause for Professor. Okay, ladies and gentlemen, next, our main session of this symposium is a presentation from our invited speaker. The audience could give the questions through chat column during the presentation by stating your affiliation, your name and your affiliation from India or from other university. And then, however, before the presentation, let me introduce you our speaker, Dr. Binitha Narayanan. Dr. Binitha is currently working as assistant professor in Sree Neekalanta Government Sanskrit College, which is a first grade art and science college affiliated to the University of Calicut and recognized as the Center of Excellence in the field of higher education by Government of Kerala, India. She graduated with her PhD from Cochin, University of Science and Technology, Kochi, India. Dr. Binitha also has published 52 articles indexed in Scopus and also contributed in 3 book chapters. Oh, great. Her Scopus Index is 19 and Google Scholar Index is 21. She also has 1 patent on preparation of fatty acid alkyl ester or biodiesel from 3 glyceride oils using rice husks as catalyst. In Indonesia, preparasi alkyl ester atau nama lain dari biodiesel dari trigliserida minyak dengan menggunakan sekam padi sebagai katalis. She has 15 years of research experience in nanotechnology, heterogeneous catalyst, material synthesis, polymer nanocomposite, and green chemistry. She also has 13 years of teaching experience in undergraduate and postgraduate program. Is that correct, Doctor?
Yes, yes. Thank you.
I would like to welcome our speaker to present her topic entitled Ball Mill Assisted Green One-Pot Synthesis of Zinc Oxide Nanocomposite for Selective Electrochemical Sensing of Aquatic Pollutant for Nitrophenol. Okay, Doctor, time is yours, please.
Thank you. Thank you, Professor Sahib and my friend Kiki.
Thank you, Dr.
Dr. Rizky.
Soon.
Let me start the
Time is yours,
presentation.
Doctor.
Okay. You can ask your doubts in between or after the talk. You can start.
Okay. Wait. Have I made you co? Yeah, or you already co-host. You can share your
Okay.
PowerPoint.
Okay. Is it visible?
Yes, it's visible quite clearly.
Okay. Then we can start.
Please, Doctor.
Okay, good afternoon to all. The title of the talk is Ball Mill Assisted Green One-Pot Synthesis of Syngoxide Graphene Nanocomposite for Selective Electrochemical Sensing of Aquatic Pollutant for Nitrophenol. Here, a nanocomposite is used for a sensing application. The components are zinc oxide, which is a transition metal oxide, and graphene. We can start with graphene. Graphene is a carbon allotrope. We know carbon is the 6th element and it has some peculiar properties of catenation. It can bond to carbon itself. It can show isomerism. It has high tendency for covalent bonding and it forms many compounds with hydrogen and other elements. And in addition to that, carbon links with carbon itself. And there are very many allotropes for carbon. Some are listed here. We are familiar with diamond, graphite, even fullerene, and carbon nanotubes are there. Even charcoal, amorphous carbon is also a allotrope of carbon. So it shows a variety in its allotropes and their properties. And in addition, many of its allotropes are nanostructures. It includes carbon nanotubes, fullerenes, carbon dots, graphene dots, diamond, graphene, and the 3-dimensional materials, graphite also. So in 1-dimensional, carbon forms carbon nanotubes and its derivatives, carbon nanoribbon. In 0 dimension, it forms carbon dot, fullerene, etc. And the 2-dimensional material is graphene. We can consider graphene or we can convert graphene to other allotropes of carbon, such as graphene quantum dot. It can wrap to fullerene. It can roll to carbon nanotube. It can restack back to graphite. Actually, graphene is the single sheet or few layered sheet of graphite. What is its peculiarity? It is a one atom thick planar sheet of sp2 hybridized carbon atom. The picture is here. There is an extended conjugation of pi bonds. So it is of very high electrical conductivity. The thin sheet is having optical properties. It is almost transparent. The material is biocompatible. It has thermal stability and high thermal conductivity too. It is chemically somewhat stable, but it can be functionalized to various other forms, and thus it can show some chemical properties. It is having high mechanical strength, and it is a two-dimensional nanosheet. The surface area of graphene comes around 2,650 meters square per gram. So it is a very large surface area. These properties makes graphene applicable in various fields. While we think of the bond length and strength of graphene, about the mechanical strength of graphene, the density of graphene is less than 1 milligram per square meter. So if a graphene sheet having a weight of the whisker of a cat, it can form 1 meter square hammock, and it can hold a cat having 4 kg weight. That is the strength of graphene. Less than 1 milligram, graphene can hold more than 4 kg cat. So its mechanical strength is very high, and the bond length is in between single and double bond of carbon. So it is having a bond strength too. As a result, it has various applications, as in conductive ink, chemical sensors, LED lighting, solar cells, flexible display, transistors, and nowadays graphene is everywhere for energy applications, etc. So for its enormous application, we have to prepare graphene in an economic and low-cost mode, and it should be easy too. We can start from graphite. There will be top-down approaches. Mechanical exfoliation, chemical synthesis are the top-down approaches, and we can build from the bottom too. CVD, epitaxial growth, etc. are the methods of bottom-up graphene synthesis. Here are some syntheses are shown here. The top-down as well as bottom-up methods are listed. It can be, graphite exfoliation can be even with light and sonication, mechanical exfoliation. In addition, we can bottom up with a CVD or epitaxial growth of silicon carbide, etc. We can start from benzene, and if we can grow two-dimensionally, it can lead to graphene. But most of these methods are tedious or costly. So usually the graphite oxide assisted route is preferred. In the graphite oxide assisted route, graphite is subjected to drastic oxidizing conditions, and as a result, different functionalities are introduced to graphene sheets, and the layer distance is enhanced. In addition, the hydrophobic graphite becomes hydrophilic graphite oxide. So water can be easily penetrated between the layers, and upon sonication, the graphite oxide is converted into graphene oxide. And it is not graphene, it is simply graphene oxide. So after reduction, it is converted into reduced graphene oxide. We cannot call it as simply graphene, it is reduced graphene oxide because some of the oxygen functionalities are there itself. In addition, the drastic oxidizing conditions causes some defects to graphene. Graphene oxide is available even in market, and it is the large scale, low cost method, and so everyone prefers for graphene oxide. But there are some functionalities even after reduction and defects in the sheets. So it will break the aromatic pi conjugative network of graphene, and it will affect the electron mobility and electron transfer. The conductivity of graphene oxide will be less than that of graphene, and so we need some less defective graphene sheets for electronic applications, but they are costly. And another issue of graphene oxide derived graphene or reduced graphene oxide is its low thermal stability. It starts to decompose from 150 degrees Celsius onwards. So we cannot apply it for high temperature applications. These are the different stages, photographs of different stages of graphene oxide preparation. Oxidizing agents such as concentrated sulfuric acid, KMNO4, etc. are used. Lots of fumes are evolving there. The temperature should be, in some stages, the temperature should be kept below 50 degrees Celsius. And as a whole, the process is highly tedious, time consuming, and it is a hazardous procedure. So we cannot apply it for applications where green chemistry is relevant, or for example, for pollutant degradation, for pollutant sensing, etc. It is not ethical. It is also not so good for the sustainability. So the defects of graphene oxide route are the defects on graphene and the functionalities on graphene, and sometimes the thickness may not be as good as that of CVD or epitaxial graphene. And overall, the process is very hazardous. So we need some green synthesis for graphene and its nanocomposites. There are many routes of green synthesis of mechanical exfoliation, or green synthesis for graphene from graphite. We are working on it, and one of the feasible route is mechanical exfoliation. The Nobel Prize winning process for graphene production is by the Scotch tape assisted exfoliation of graphite. It is a repeated peeling process. And finally, we are getting single layered graphene, but it may take few days or few weeks to reach to that. It is a tedious procedure, and it is not so able for bulk fabrication. Sonication, fluid dynamics, etc. are other mechanical means, and one of the promising mechanical means of graphene exfoliation is via ball milling. In ball milling, graphite is subjected to balls. Milling occurs while rotating the medium. And if there is milling agents, they can assist the exfoliation of graphite. Graphite exfoliation can be done via shear force only. The action of normal force on graphite will lead to its fragmentation. So shear force dominated exfoliation only will lead to less defective graphene sheets. This is the process for non-protected ball mill exfoliation of graphite. We can see the graphite sheets are broken there, and finally it will result in amorphous carbon. So it is not so recommended. But while we use protected exfoliation of graphite in the presence of other milling agents, the shear force dominated exfoliation of graphite occurs, and we will be getting high quality graphene sheets. We have tried this method for the large scale synthesis of graphene, and our milling agent is low cost sucrose. Here, graphite is mixed with the sucrose first, and then it is undergoing ball milling, and the ball mill mixture upon calcination lead to graphene. In addition, this is hydrophobic graphene. In addition, we can mix graphite milled mixture in water. We can disperse in water either by sonication, and the sucrose ball mill mixture is dispersible in water even without sonication. So aqueous processable graphene can also be produced by this route. These are the different photographs of different stages of ball mill exfoliation of graphite with the sucrose. The carbohydrate moieties can additionally stabilize the graphene sheets, and it will lead to exfoliation. And this graphene is dispersible in various solvents, various organic solvents. It can also mix with the water before calcination for producing aqueous processable graphene. Ball milling with, in addition to sucrose, ball milling can be done with other milling agents too. Dry ice is a commonly studied exfoliating agent of graphite. In addition, melamine, oxalic acid, etc. were also tried. And before the exfoliation of graphite, it can be subjected to drastic exfoliation, drastic conditions for the initial exfoliation, and then the ball milling will be more effective. For example, graphite can be milled with the sulfur to produce graphene sulfur nanocomposite. But initially we need a sulfuric acid, nitric acid treatment and a high temperature treatment in inert condition. But the treatment with the corrosive acids are not so recommended, but it may not last for hours as in graphene oxide. Then another exfoliating agents are PVP in the presence of supercritical carbon dioxide. And even inorganic salts such as alkali metal salts, potassium carbonate, sodium carbonate, etc. can be used for the exfoliation of graphite. And one of the graphene polyaniline composite is prepared by ball milling graphite with aniline in the presence of sulfuric acid. And after that, the ball mill mixture is subjected to mechanochemical oxidation polymerization for the preparation of graphene polyaniline nanocomposite. So in situ preparation of nanocomposites are also possible by ball milling. Graphene nanoplatelets, not graphite, graphene nanoplatelets. Few layer graphene is ball milled with a nickel acetate to form a nanotube decorated nickel deposited graphene sheets, and it is additionally decorated with palladium to form a composite which is a highly active catalyst. So there are lots of possibilities for the incorporation of other materials to graphene and also for the ball mill exfoliation of graphene. And why we prefer the formation of nanocomposites? Because the high surface area graphene matrix can act as a suitable support material for the incorporated species. And since the surface area is very high, very low amount of graphene can show substantial enhancement in the activity when compared to conventional composites. In addition, the remarkable properties of graphene can improve the physicochemical qualities of the nanocomposite. And the synergistic properties of the components can result in advanced properties. Here, our component is zinc oxide. Zinc oxide is a highly well-known material. It is having a woodside structure, and dissipation of zinc oxide on graphene can lead to synergistic properties to the nanocomposite. The zinc oxide is cost-effective. It is not so costly, and it is non-toxic too, and it is naturally abundant. It has high photocatalytic performance. It has good electrochemical properties and is also used for sensing application, especially in gas sensing. So zinc oxide is a suitable material for wide range of applications, including biological applications in drug delivery, even as medicine it can be used, nanomedicine. It is an anti-cancer agent. It is a biosensor for various biological molecules, and it is an antioxidant too. So for the sensing of a variety of molecules, we can use zinc oxide. And here we prefer its use as for the sensing of a phenol derivative for nitrophenol, which is an aquatic pollutant. In addition, graphene itself is also functioning as a sensor material, and incorporation of foreign species to the graphene matrix will enhance the properties of graphene, facilitating its sensing applications. But the challenges of graphene in its wide use are the requirement of less defective graphene sheets for electronic or electrochemical application, and green chemistry prefers the use of less toxic solvents for the exfoliation of graphite. And usually graphite exfoliation is a multi-step process, and we have to add another step for the introduction of or the incorporation of metal oxide. So the remedies are preparation under mild condition with the use of milling agents, surfactants, indicalants, green solvents, etc. And one-pot techniques are needed for the exfoliation and further composite formation. And in addition to improve the properties of individual components, the metal oxides or any other component can prevent the layer restacking of graphene back to graphite. So the present objectives are one-pot preparation of zinc oxide graphene nanocomposite, and the preparation is done via metal oxalate assisted exfoliation of graphite via ball milling. The prepared material is characterized to investigate its properties, to check whether it is feasible for electrochemical response, and we had applied it for the selective electrochemical sensing of 4-nitrophenol. The experimental section is different photographs of the experimental section are shown here. Initially, graphite powder is mixed with the zinc oxalate, forming a mixture. We can see the color, but after ball milling, the color is changed to almost black, indicating the incorporation of zinc oxalate between the graphene layers. And after calcination, zinc oxide graphene nanocomposite is formed. The material is characterized using various techniques to investigate the structure. And our application is electrochemical sensing. We have sensed 4-nitrophenol in the presence of other interfering reagents such as uric acid, hydrogen peroxide, ascorbic acid, glucose, etc. Because sensing should always be selective. Otherwise, we cannot ensure that it is a single component. Or if the selectivity is very low, we cannot say it is 4-nitrophenol or uric acid or whatever it is. This is the photographs for the electrochemical sensing investigation using an electrochemical analyzer. The graphene, zinc oxide graphene is coated to a glassy carbon electrode for its sensing. About the results obtained and the discussions. The X-ray diffraction patterns indicates the peaks corresponding to Woodside Sedano. In addition, there is a broad band of graphene. The broadness of the band at around 26.5 degree indicates there is a mild layer exfoliation only. If there is a drastic layer exfoliation, the peak will be shifted from 26 to around 10, 15, etc. So this indicates the graphene sheets are not fully functionalized, but there is somewhat functionalization, and we hope the functionalization is there in the edges. The FTIR spectroscopy results confirm this because there are peaks corresponding to COC as well as COH vibrations in graphene, in addition to the peaks of Sedano at 604 and 436 and the band for graphene at around 1587. So it indicates the functionalization of graphene, and from X-ray diffraction patterns, we can say that the functionalities are incorporated to the edges of graphene sheets. The merit is that the pi conjugation is unaltered there, but the functionalization will improve the properties of graphene. The Raman spectroscopy result indicates the less defective nature of the prepared graphene. The ID by IG value, it is an indication. This is the G band, its intensity is IG. This is the D band, its intensity is ID. The ratio is less than 0.5 and it indicates the less defective nature of the graphene sheets. And there is a peak around less than 1000, and these peaks corresponds to the presence of Woodside Sedano. So the formation of a good composite is also well established here. This is the TEM images of the graphene zinc oxide nanocomposite. The bunches of zinc oxide spherical particles are dispersed over graphene sheets. And the lattice fringes corresponding to zinc oxide are also visible in the high resolution TEM images. About the mechanism of formation. Initially, graphite is ball milled with the zinc oxalate. Zinc oxalate species is incorporated between the layers, and after thermal treatment, it is converted into spherical zinc oxide bunches decorated graphene nanosheets. It is evident from the TEM photographs. Next, about the application, which is 4-nitrophenol sensing. 4-nitrophenol is mainly used in the manufacture of drugs, fungicides, and dyes, and it is also used to darken leather. So its requirement is high, but its disposal will lead to environmental pollution. It is of acute toxicity, and so we have to remove it before their disposal. Before disposal, we have to sense its presence in the medium. So sensing is highly important. The presence of 4-nitrophenol reduces the ability of blood to carry oxygen. So it may end to the death of the animal. So its sensing is it's a high requirement. Here is the cyclic voltagramma of the selective sensing of 4-nitrophenol. The sensing is performed in the presence of other interfering agents such as glucose, uric acid, ascorbic acid, hydrogen peroxide, etc. And none of the interfering species has produced any peak in the cyclic voltammetry. But the peaks are present only for, the peaks corresponds only for 4-nitrophenol. The irreversible reduction leads a peak here. It is for the reduction of 4-nitrophenol to aminophenol. And it undergoes a reversible reduction to nitrosophenol. And the peaks, reversible reduction peaks, the anodic peak is shown on the top and the cathodic peak is shown in the bottom. This is the electrochemical reduction mechanism of 4-nitrophenol. 4-nitrophenol is initially reduced to 4-aminophenol and then it is reversibly reduced to 4-nitrosophenol. The peaks are well visible in the CV photographs. So in conclusion, here a novel facile green one-pot ball mill assisted method is developed for the successful preparation of zinc oxide graphene nanocomposite. Here for the first time, a metal oxalate is used as the milling agent for graphite exfoliation. The material characterization studies reveal the less defective nature of graphene and the formation of a hybrid nanocomposite of well-dispersed woodside sedano nanoparticles over graphene. The selective electrochemical sensing of the nanocomposite towards 4-nitrophenol is well established using cyclic voltammetric analysis. These are some of the references. I would like to acknowledge my MSc student, Ms. Kavya P, for performing this work as her MSc project work. I would also like to thank our college and University of Calicut for providing the facilities for carrying out the project work. The research scholars, teaching and non-teaching staffs of Department of Chemistry is acknowledged, and our funders and the institutes for analysis. And now the Teknomekanik journal and the officials are also acknowledged. This is my research too. And graphene is a material that has outstanding properties and it can be applied anywhere. And now it is there for the treatment as well as for the destruction of coronavirus too. Thank you all. Thank you for your kind attention.
Okay, thank you, Dr. Binitha. Please give the applause for the impressive presentation from Dr. Binitha. It's very impressive presentation. Now we come to a question and answer session or discussion session. Anyone can raise your hand and or unmute your microphone to ask the questions. Is there anyone from the floor? You can unmute your microphone to ask the question and we can start the discussion session. Anyone? Okay. For Indonesian students, untuk mahasiswa Indonesia, Ananda boleh mengajukan menyiapkan pertanyaan dalam bahasa Indonesia, nanti akan ditranslate ke dalam bahasa Inggris. Silakan kalau ada pertanyaan. Okay, Dokter.
You can type in the chat box too, if we can.
Yeah, from the chat box. Otherwise, Dr. Binitha will answer some questions that were sent to us during the presentation. One question first or more than one, and then you can answer, Doctor?
Yes.
One by one?
Yeah.
Okay, I collect the question first from Indonesian student. What is the impact of a zinc oxide graphene composite toward the tensile strength or mechanical properties of ball mill? Because most of them are from mechanical engineering department.
Yes.
So they
Actually,
ask about the impact of your composite toward the tensile strength or mechanical properties of ball mill.
Okay, actually we didn't analyze the mechanical strength, but this graphene nanocomposites are even applied in aeroplanes as the external coating. So it is of high mechanical strength. Usually graphene nanocomposites have high mechanical strength. We didn't analyze because our part is sensing.
Okay, in industry, Doctor, the application in industry, is it new material or already?
Zinc oxide graphene is a non-material, but our route is novel.
So is categorized in the new material of nanomaterial.
It is the preparation route is novel. Material is known. Zinc oxide graphene nanocomposite is known. For photochemical applications, everywhere it is there. But the synthetic route is novel. We first report this mode.
Yeah, so it's a lot of novelty in your research. It's a very impressive. Another question? You can raise your hand before I come to the second question. Atau audien yang dari Indonesia, Anda boleh menggunakan bahasa Indonesia dalam menyampaikan pertanyaan. Nanti panitia akan ataupun saya akan mentranslate-nya dalam bahasa Inggris. Silakan, dipersilakan. Anyone? This is no material. In mechanical engineering, we also have the core material, nanomaterial. So this is give a great advantage for us and also for our journal. Anyone? If no one raised the hand, maybe I will come to the second question. You say that one pot technique to produce the composite. Is that right, Doctor?
Pardon? Can you repeat?
You use the one technique, one pot technique to synthesize the graphene composite.
Yes.
Is there another technique to produce this composite?
Actually, for the preparation of Syngoxide graphene nanocomposite, first graphene is prepared. Graphite is exfoliated. The first part is I had shown in the initial slides for the preparation of graphene oxide. First graphene oxide is prepared. Then zinc precursor is added to that medium. And then it may be subjected to hydrothermal treatment or microwave treatment. And after that, we collect the mixture, we filter and calcine. So there are two steps: initial for the preparation of graphene, and then only the zinc precursor is adding, and then further processing. So usually two pot techniques are there.
Oh, two or four
multi-step. Yeah, multi-step
combined. Compare with the stated or established procedure or technique? What is the
Yes.
novelty of your research?
Compared to the non-technique, our time may be almost same, but our method is highly facile. The other method is just like we have to control the temperature always. We can only do it in a fume hood, and we have to control the parameters always. So our attention is fully needed for preparation. But for ball milling, we just keep the ball mill on, and after 48 hours, we can stop ball milling and can just calcine the material to get the composite. This is a simple method.
Okay. Thank you, doctor, for the explanation. Is maybe if I in your field, I also interested with your and okay, maybe I will collaborate with you.
Okay,
to the
okay, thank you.
research. But my field is in energy. One question from Indonesian student. He would like to ask about graphene as mentioned in your presentation. It is a very good conductive material, or in my note, high conductivity. Graphene has a high conductivity. Can you use the Can you use the graphene in the cooling system, such as cooling computer, as the conductive link between the processor or other electronic that need cooling to the heat sink? Will the graphene endure the heat? That's the question from our student.
Actually, graphene can conduct heat too, but it is a thermally stable material if we are preparing less defective graphene. Graphene can conduct heat. Its conductivity for heat conductivity is very high. For the electrical conductivity, it comes for one of our graphene nanocomposite, we have obtained 10 raised to 6 Siemens per centimeter. The conductivity is just like metallic conductor, and it can conduct heat too. So it may not be useful for cooling applications because it will conduct heat, but it can replace the materials because it can withstand heat. It will not damage the computer or everywhere. Even in displays, graphene is using. For touch screen also, graphene is using.
So it can endure the heat. What about the comparison with the graphite, more pure graphite? Or we call in a carbon, pure carbon?
It is pure carbon.
It's a pure carbon.
Difference is that the hybridization of carbon is sp2. There is pi conjugation throughout the matrix. Bond length is between single bond and double bond, and thus bond strength is very high.
Okay, please unmute your speaker, your microphone, or otherwise you will ask the question. Okay. Thank you, Doctor.
Okay.
You can add your explanation.
Yeah, I have completed it. The graphene strength is very high.
Very high. Good.
Yes.
Actually, with it's good conductivity, it's a good tensile strength, and also have a good mechanical properties.
Yes, yes.
But in application, especially in mechanical or material in industry,
is limited because the low-cost technique is graphene oxide route. The graphene oxide is a functionalized graphene, but it is not possessing most of these properties. If even at temperature higher than 150 degrees Celsius, it starts decomposing. So we need some cost-effective modes like this ball mill, graphene, etc. for its widespread applications. To explore all the properties of graphene, we need to prepare less defective graphene in a cost-effective manner. Then only it will come to industry. Now some samples are, it is almost applied everywhere, but its economical production is an hindrance in this area. But these ball mill assisted techniques can overweigh. It can enhance the application of graphene.
Doctor, thank you very much for your explanation. Anyone? Okay. Anyone who wants to ask the question? Oh, we have one question again from our student in automotive department. Can we use this technology in automotive?
Automotive field, this field is new to me, but
Yeah.
graphene composites are applied everywhere. Even it can, its coating is highly stable. It can be used as a non-corrosive thing. Can lead to non-corrosive coating, even for vehicles, etc. Graphene paints can be used. So graphene
So
coating is non-corrosive. We can protect materials.
So it can be as a corrosion
Resistant
resistant
material. Ah, yes, yes.
Because it coated the material, the material.
Ah, yes, yes. It can, the coating can prevent corrosion.
Any material that that can be coated by this
Ah, yes,
composite?
yes, yes, yes. Any material can be coated.
Is good. So far, what is your implementation or application using your composite, doctor?
We are mainly doing electrochemical application and in catalysis, also for photodegradation of pollutants. And we are also trying for supercapacitor applications. Graphene
Also for
supercapacitors, sensing also we are doing. Supercapacitor applications also we are doing. Instead of battery, we can maybe later supercapacitor powered, graphene powered vehicles will come. So there won't be any pollution.
For aeroplane, is maybe can be used for aeroplane material.
Aeroplane maybe it is a developing area. It can come everywhere.
Developing area.
Yeah.
Maybe you can research for further research. Your further research.
We are doing one project on supercapacitors for its device applications.
Thank you, Doctor. There is the one question. It's very interesting and impressive article. So many questions come into the chat column.
Pardon? Can you repeat?
My student asks you about the nanomaterials. Do you think nanomaterials will advance rapidly in the future, while in the industry not many use nanomaterial system? Can you get my
Yes. Industry started to use nanomaterials.
Yeah, not many industry use this material.
It is coming. And even nanomaterials are used in automobiles for the pollutant control, for the exhaust emission control, etc. Nanomaterials are nowadays also using. Even in our vehicles, there is a catalytic converter coated with nanomaterials. They will reduce the emission of pollutants. So nanomaterials are using here and there. And about the nanomaterial pollution, we have to use everything in the right way. If we use a coating application of a nanomaterial, it will be very fine. But if we just pour the powder in the atmosphere, it will definitely cause pollution. So we have to use the material in the right sense. That is highly important. And in addition to other nanomaterials, graphene is just like a sheet material. It is not so penetrating just like other nanomaterials because its length may come even in the micro range. Even the thickness lies in the nano range. The length may be microsheets. So it may not be easy to penetrate inside the body. Another thing is that even graphene-based materials are used in drug delivery. So the material is biocompatible and safe to our body too. Hope you are clear.
Yeah, you also already answered the next question. What is the implication of nanomaterial on human life?
Okay.
Okay, another question, please. You get greeting from Taiwan.
Hi.
Any question from the floor, please? Or from your students, doctor? Any question?
For my Malayali students, ആർക്കെങ്കിലും എന്തെങ്കിലും സംശയം ഉണ്ടെങ്കിൽ ചോദിച്ചോളൂ ട്ടോ.
You have your own lab to develop this composite?
Pardon?
Do you
yes,
have
yes, yes,
your
yes,
own lab, your own
Yes.
group research
Yes, yes. We
to
have.
develop this composite?
Yes, yes, we have.
It's good.
We have one lab as our own.
Okay,
Excuse me, Mrs.
the next
Kiki.
question. Since graphene has conductivity, what is the best application of graphene in nanomaterial? I think this question, maybe you can more explanation on this application. Because
Based
this
on
is
the
novel.
conductivity, graphene can be used in electronic applications. And also for capacitors, sensors, everything. Electronic conductivity is helpful for these applications too.
Any
Batteries,
exception?
even graphene derived batteries are also coming. Rechargeable batteries.
Otherwise, oh yes, good. However, doctor, is there any restriction of some certain condition that we cannot use this composite?
No,
Or
up
limitation?
to now there is no restrictions for the use of graphene.
Oh, so it has a wide range of the application.
Yes, yes. In India, one or two companies are also there for graphene research only, and the products are coming. I have shown initially the photograph of a graphene oxide bottle. They are marketing it in Bangalore. They have anti-corrosion coating of graphene too.
yeah,
They are also using in cements, paints to increase the mechanical strength. It is also used in cement. So it has mechanical applications too.
In India also has the research on this graphene composite.
Yes, yes. Graphene is now widely used everywhere. Now research is beyond graphene too. This kind of two-dimensional materials are emerging.
Okay, doctor.
Okay.
There is one question. It's a very interesting question. He wants to ask about graphene oxide. Is it dangerous for graphene oxides to our body? While there is the news that the COVID-19 vaccine contains graphene oxide.
Actually, I don't know about the component of COVID-19 vaccine as graphene oxide.
Vaccine
But-
oxide. What type?
But graphene oxide is a safe material once it is prepared and purified. We can use it for drug delivery too. So it is safe in the body. But inhaling graphene oxide may not be good. But usually it is a microsheet. So it may not be easily going inside.
Okay, doctor. Maybe there is one question. Aprizal, you can raise your hand and also unmute your speaker, your microphone to ask the question to Dr. Binitha. Time is yours, Aprizal.
Yes.
Okay.
Thank you, Mrs. Kiki. Before I will introduce myself, my name is April Saputra. I'm a student Mechanical Engineering, Faculty of Engineering, Universitas Negeri Padang.
Okay.
Now I'm focused write my paper about the thermoelectric. Where the thermoelectric has two sides, namely the hot side and the cold side. This thermoelectric can produce electricity with a temperature different between the side. Currently, I use the sun's head as head source. Can this composite be used to retain head or be cold source for thermoelectric, Mrs. Binitha?
Can you repeat the question, Kiki? I'm not so clear. Sorry.
Okay. Aprizal asks about the composite, your composite, nanocomposite as electron transfer layer for
Yes, yes, it can be used.
solar cell.
It can be used as an conducting layer. It can be used.
It can be used. And what is the effect of the graph concentration on a photovoltaic performance?
For photovoltaic performance, we didn't try
photovoltaic.
it. but still graphene is widely using. There, we may need high concentration of graphene. For catalytic application, the graphene concentration required is only 2%. But for electrical applications, it may be good if we have 50% of graphene or more. Are you clear?
Very clear?
How to make
Aprizal, or are you want to ask me some question again?
Yes, I'm okay.
It's
Thank
clear
you.
enough for you?
Yes, it's clear.
Okay, thank you.
Thank you very much, Doctor, for your explanation and also discussion. Maybe we have another question, Doctor?
Yes, can.
I have this in the column, but wait. Farhan Hakim, you can raise your hand and unmute to ask the question. Farhan, are you there? Farhan? I will deliver the question. Production of carbon-based products such as graphene, does the production change in the factory produce a lot of emission? He asks about the emission of your composite.
Okay. Emission of graphene oxide is there. If we are preparing graphene oxide, we should be very careful. We have to do the preparation in a fume hood, and the fumes should be properly disposed. But for our preparations of graphene, we are not creating any toxic gas evolution. So it is highly safe and it is low cost too. So these kinds of things should come to technology for the widespread use of graphene. Hope you are clear.
Yeah, I think it's quite clear because you mentioned early, you prepare the composite in a fume hood.
For graphene oxide only, we need fume hood because there are lots of corrosive sulfuric acid, KMNO4, lots of fumes will be evolved definitely. So the preparation should be in a fume hood. But ball milling is a solid technique. There won't be any evolution of fumes. It should be properly closed. That's the only requirement. And calcination we are doing in a muffled furnace. Still there is no lots of emission. Only carbon dioxide is maybe emitting there. It should be properly disposed.
How do you set your lab to keep it safety for your work?
We are not doing any harmful gaseous emission in our works. So even without a fume hood, our labs can work properly. We are not using any toxic organic solvents such as DMF, NMP. These solvents are usually employed for graphene processing, but we are not using any of such solvents. Our solvents are water, ethanol water mixture, and maximum isopropyl alcohol water mixture. That ends our solvent system. We are not going to any toxic solvents. So our lab is a green chemistry lab. There won't be any emission.
Yeah, because your lab is the lab of the green chemistry. So
Yes. We are sticking on green chemistry for our research.
Thank you, Doctor. Another question. My student currently doing research on thermoelectric, where the thermoelectric has two sides, namely the hot side and the cold side. This thermoelectric can produce electricity with a temperature different between the two sides. Currently, I use the sun's heat as a heat source. Can this composite be used to retain heat or be a cold source for the thermoelectric?
I'm not doing any thermoelectric applications, but these Syngoxide graphene composites have a photocatalytic property. It can absorb light. Even UV light, it can absorb. But the temperature difference, I'm not an apt person to answer. I'm not doing that way.
You're not doing in a thermoelectric.
No, I am not doing.
You're doing in a sensing, right?
Sensing, catalysis, supercapacitor, etc. is there. We are not doing any thermoelectric applications. Usually graphene can be we can say it as sometimes the composite can act as a semiconductor like material. So with temperature, the conductivity will increase. There won't be any decrease. For metals, if we increase the temperature, the conductivity may decrease. But for these kind of materials, with increase in temperature, the conductivity will also increase. So it will not affect the electric properties of the material with increase in temperature.
Increase in the temperature.
It's
Doctor, thank you very much for your explanation. Another question, please raise your hand. Anyone? Or from your student, doctor?
May not be asking, or no. If anybody have any questions, can ask.
You can raise your hand.
Or you can type in the chat box too.
While we are waiting for the question, I remind you to fulfill the present to the attended list in the column, in the chat column. And also subscribe our channel, YouTube channel, as stated in the flyer. Okay, have you? Has a question, another question? If there is no question again, maybe we can close our discussion session.
Okay.
Okay, doctor, thank you very much for answering this question and for the great presentation. I hope this will be give the great advantage for the audience. For further information about the articles, Dr. Binitha's article, you can access our journal as stated in the flyer and the poster. So keep up our poster or flyer. It will be published in the next issue in our journal. Okay, doctor, is this a happiness especially for me to have you here with us, doctor?
Okay. Thank you very much.
This is your certificate.
Okay.
Here is your certificate and it will be sent to your email soon.
Okay, okay.
Finally, we would like to appreciate to you, doctor, for your contribution in our event and journal. We also would like to appreciate all audiences for your active participation, even in the chat column. Maybe they will sigh to deliver the question directly in this event. 2021 starts at 3 p.m. Western Australia time with Prof. Hui Tong Chua as a speaker. The topic is ground source heat pump and air source heat pump performance comparison for domestic application, a case study in the Perth, Australia. So don't visit our next symposium with professor from the Australia. Don't forget also to subscribe our channel, YouTube channel, as stated in the chat column. Hopefully, this symposium will be beneficial for everyone. Is it vision our channel YouTube? Doctor, don't forget to ask your
definitely,
students
definitely. Okay, okay.
to subscribe our channel. I hope you. Thank you very much for your contribution in our.
Thank you, the organizers and also the
symposium.
audience.
I will share the second symposium, the link and also the flyer for you, doctor, and also for your student, and also for the others. Great advantage and impact on you. Thank you all and see you in the next symposium. Wassalamualaikum warahmatullahi wabarakatuh. Bye-bye, Dokter.
Okay, thank you. Thank you all. Bye.
Thank you very much. We can close this
Okay.
symposium. Oh yeah, for the audience, the certificate will be sent to the email. The email that you registered in the registration link. Yeah, we will send you the link of the link of the certificate. Okay, thank you. Bye-bye, Dokter.
Okay, bye.
Bye. Saya mariga to Srija and Suraja. And also I see the Tusara there.
Oh,
Thank you. Bye-bye, Dokter.
okay, bye, bye.
See you in the next symposium.
Okay.
Thank you very much.
Di alam mo rin, di ko sa ito yang apa yang